Okay, let's begin.
You want to share screen?
Nanda, yeah, Nanda, if you can share screen.
Okay, yeah.
All right.
1 second, let me switch on my video. How do I do that? Yeah.
Okay. So, greetings everyone. I am Sourav, an academic researcher at the University of Melbourne, and we are in the second week of ISDAIOT Symposium, and this is the first session of the Data Analytics Workshop. This workshop is organized as 4 sessions on Thursdays of every week from 5 to 7 p.m. and is being supported by IEEE Victorian section and the Student Engagement Grant Program at the University of Melbourne. Nandakishor, another academic researcher at the University of Melbourne, is the workshop chair for today, and we will be handling alternative sessions. Before we discuss further, let me give you my belated wish for the IEEE Day. So IEEE Day is celebrated on the first Tuesday of October, which was the day before yesterday. So this is the IEEE week, and all the IEEE volunteers and enthusiasts around there. So now we engraved in its essence, the IEEE Day's theme is leveraging technology for a better tomorrow. So that's all about IEEE Day, and let's begin with the workshop. So I'm handing over the session to Nanda.
Thanks, Sourav. I guess, shall we start, Noor?
Yeah. That sounds perfect.
Okay. Hi, everyone. Sorry?
Sorry to interrupt. Can you please keep your mic closer? I think.
Oh, okay. Am I not audible clearly?
Yeah, I think you're better now. Yeah.
Is it better now?
Yeah.
Okay. Just this one. Yeah. Hi, everyone. As Sourav introduced, I'm Nandakishor. I just recently finished my PhD from University of Melbourne. So this is a collaborative event between the IEEE organization and also supported by the student grants from University of Melbourne. So we'll be conducting it as a series of 4 workshops split into 2-hour sessions every Thursdays from 5 to 7. So every Thursdays from 5 to 7 Australian time, of course. So without much delay in that, let's get started with the workshop outline. So we have this is a very approximate outline. There will be changes as we go forward depending on the feedback that we receive from you. Today we'll be starting with fundamentals of data handling. When I say fundamentals, especially what sort of tools you need for analyzing the data and how to handle the data. So which means one of the important tool is a programming tool for which we will be using Python. So today, mostly I'll be introducing you to Python and sort of how Python works, what are the salient features of Python, how do you write some basic codes using Python, and what are the simple data structures. Before we move on to second session, where we will be discussing essential libraries, Python-based libraries that are important for data science. So if you want to analyze any of the data sets or for any application, if you want to perform some data analysis, what are some of the important libraries? Like you might have heard of libraries like NumPy or SciPy or Matplotlib for visualization purposes, or maybe a Scikit-learn, which is mainly a machine learning based library, or it might be a Pandas, which has got a lot of efficient data structure, data science handling capabilities. So we'll be introducing that in session 2. Before we move on to some preliminary data analysis and how sort of data pre-processing, all those things in session 3, ending with a moderate level, a mini project sort of thing in session 4 on a time series data set. So as you can see in the name, so time series data set is something like where you have some sort of data captured over a period of time. So any sort of quantity that is captured over a period of time. So how do you analyze that and sort of analyze the trajectory with respect to time, those sort of things. So today is session 1, fundamentals of data handling. So where I'll be discussing these 4 key things. So what is data analysis? Just a very brief introduction into the world of data analysis. And then why do we use Python compared to other programming languages? Python data types, and finally Python data structures. Now, before we move forward, so because this is first session and I understand we have sort of audience from a diverse background, so we are just trying to keep it as simple as possible. So it might come off as little slow or very too little content for this particular workshop. But because of that, also we are also floating a sort of Zoom poll, just getting feedback from you regarding the understanding that you have, the skill set that you have in Python, just whether you have you know about Python beforehand, or is it something that you want to study now, or do you have some moderate understanding? So feel free to interrupt me at any time and give me your feedback so that in the coming session we can go faster or slower depending on how we require. So what is data analysis? So data analysis is just a process of systematically applying your statistical or logical techniques, so to describe and illustrate and condense and recap and evaluate data. So it's just like you will have a lot of data. So especially with the evolution of internet, there is just like an explosion of data. You see data everywhere, like every single aspect of life, be it like how Google gathers data from us or in social media. I mean, every single aspect, from your grocery shopping to your health, to your just standard shopping things, or to your sleep patterns. It might be any single aspect of your life. There is some data associated with that. So when I say data analysis, what it means is that just structuring that data properly. Like for example, say you want to analyze sleep patterns. So there are a lot of, say nowadays you have got wearable devices and things like that, where you gather data from someone's, like put a wearable device and gather data from the person's sleep patterns, and then try to analyze what are the sleep patterns, and then say whether there is any correlation between that sort of different sleep patterns or some abnormal sleep pattern and some sort of diseases or some disorders. So there is just no end to anything. There is just no limit to the imagination. So when I say data analysis, so you just gather all of this data and then just sort of try to structure it properly so that you get some useful insights out of it. It might be just like a big pile of sort of thing where you have to structure it properly so that out of that data you get some very important insights that you use to make it. It might be, your goal might be anything. So your goal might be that you just want to understand what is present in the data so that in future you can gather better sort of data. Or it might be that using that data you want to make some predictive information, like predict something, or you want to model some sort of phenomenon that explains some physical process in real world. So there is no limit, and there is absolutely no single area where data analysis does not find its application. So it helps you discover useful patterns and information, and of course assist in predicting unknown or future information. So as I said, if you want to sort of give keywords to those sort of analysis that I mentioned, so it might be like a descriptive analysis where you just want to describe a particular data through some important measures. Or it might be diagnostic. So you want to understand what happened or like some phenomenon. It might be in a health scenario, or it might be anything. It might be predicting an election outcome, whatever it is. So which means predictive would involve, obviously you would have come across a lot of election predictions, or say, yeah, I mean, weather predictions. Again, predictive modeling is something that is there in, again, every aspect of life. And so there are different aspects to data analysis, and it has got a wide range of applications, from healthcare to internet to smart city. So like healthcare is where like you have got wearable devices, for example, your sleep patterns, like how I mentioned earlier. Then there are like works where there is one recent work where they try to predict influenza outbreak from wearable devices. So how what's your activity level, and gathering those sort of information, they tried to predict the influenza outbreak, which they were also repurposing for a similar tracking in COVID-19 sort of cases in scenario. Then you have got smart city, so which is sort of the buzzword nowadays. So where governments anywhere in the world announce, okay, we'll make this XYZ smart city. So where lot of small processes, or a lot of small, like it might be some work with the local city corporation or things like that, that will be automated. Or it might be some sort of energy monitoring, where you'll have smart energy monitoring that optimizes your energy usage. Or it might be a transport where like you have with Uber and other shared taxis and things like that. So it's probably easier to list an area that does not use data analysis rather than listing the areas that use data analysis. So this is a pretty standard pipeline for a data analysis sort of framework or approach, where there is actually two important stages. One is you acquire the data. So like, for example, again, if we go back to the sleep pattern example, so we have the wearable. So you put the watch on the person's wrist and then gather the data. So that is the first step where you acquire the data. Then the second stage is analyze that data. So you can see here there are two, which is data wrangling and data processing. So data wrangling is more like just cleaning up the data and structuring it and sort of thing. Then data processing would be final analysis and processing that you would do. So as you can see here, next to data acquisition, there are different types of data. Like it might be a one-dimensional data, or depending on the dimensions. So like it might be a one-dimensional data, for example, a ECG curve. So it's got just say an amplitude that varies with respect to time. So you just have one dimension. So there is just one quantity that varies with respect to time. So that is a time series curve. So it's a one-dimensional data. So then you have got image data, so which is basically two-dimensional data. So where you have got an X dimension as well as a Y dimension. With respect to X and Y, the value varies. So you got, so it might be any natural images, or it might be your X-ray medical images. It might be CT medical images. Then you have got 3D data, which is like, for example, volumetric images. Like in case of some medical image scans, you have got X, Y, and also along Z direction. So it's more like a volume of image. Or it might be a video where your X and Y dimension will be your image dimension, and the third dimension will be that of time. Because video is essentially that image changing with respect to time. So depending on, so each of these data have their own advantages and disadvantages. So the multidimensional data capture different variations, but then they are a little harder to process in the sense that they require more computational power. Although computational power is not a big deal nowadays, because you have got a lot of graphics cards and super performance computers. So it's very much easier. But yeah, but like for example, but that would require little more time. So for example, with 1D data, like the sleep performance thing that I told, so those watches itself will have many algorithms and sophisticated data analysis approaches locally, that like those things will be done locally and will give you newer insights. Now this sort of local processing is also possible because you have got sort of simpler data and sophisticated algorithms. So there is a whole lot of dimensions to this data analysis problem. So there is one key aspect of data acquisition and one key aspect of data processing. So we will, of course, ignore the data acquisition part for this workshop purpose. We will assume, say, we have got data set. So we are only concerned with the other stage, which is data analysis. For the second stage, what we need is the tools that we use to perform data analysis. So like, how do you load the data onto the computer and then analyze that? So for that, you have got a range of tools, as you might have come across. So it might be Python, it might be R, it might be a Java, or it might be something like a Matlab. So each of these languages have their own advantages and disadvantages. Like Matlab is a proprietary based one, and Java is basically more useful for web application sorts of development. So for example, Python, some of the important features, why do we stick to Python? So one of the important thing is it's a very general purpose, high level programming language. And it's got a syntax that is pretty much similar to your usual English structure. So you can write your program just like how you would normally write an English sentence. So it's not far off from that. So that sort of gives you a better intuitive understanding of what is happening and how you can if you have a bigger problem, how you can split that problem into smaller chunks and then write your programs to sort of solve those particular smaller objectives. So it provides a powerful environment for scientific computing. It's much faster and more scalable. And also, of course, you have got a lot of wide range of efficient libraries like NumPy, SciPy, Matplotlib, etc. Another important thing with Python that you should remember is it works with the interpreter. So opposed to, say, a programming language like C, which mainly works with a compiler, the key difference is when you run a C program, so your program has to compile before you can run and decide what sort of error it's there. So whereas Python directly works with the interpreter. So even if, say, you have written 10 lines of Python code and there is an error in 10th line, the 9 lines of code will still run until it hits the 10, opposed to, say, a C where it has to compile before it can run. That's one of the key difference in Python. So that's what I mentioned. So it's an interpreted programming language. So it basically works with the interpreter as opposed to, say, a C programming language, which works with a compiler. It's got very efficient high-level data structures and simple but effective approach to object-oriented programming, which I hope most of you would know. So where you declare classes and inheritance and object-oriented programming. Other important thing is, so it relies on indentation. So Python relies heavily on indentation. Like when you would define your standard if statements or a for loop, things like that, they need to be properly indented. So this indentation, it relies heavily on indentation. It would not work without that. So the indentation using white spaces so that you define properly the scope, which we'll understand as we go through the programs. And it has got very simple but effective, like cross-platform compatible libraries. So it works equally well on your Unix systems, so Windows, Macintosh computers. So coming to the practical aspects of it, there are wide variety of IDEs, that is the development environments for Python, and how you install. So I assume most of you have already Python installed. Most of the computers actually will already have Python installed. So there are a lot of IDEs that you could use for developing some simple programs in Python. So one of the popular ones, which we will also be using, is Jupyter Notebook. So which is open source web application. So it allows you to create, like, you can write your codes, test small snippets of codes. You can even write your equations that you might be implementing or like properly comment. So it sort of acts on, you can create a Jupyter notebook as an independent or a standalone document that describes whatever theory things you might have, like some particular description about the data that you are analyzing, or some particular type of math equation that you're implementing, as well as your code. So all of those things can be put together and you can sort of create it like a standalone thing. Then you have got Anaconda, so which is a free and open source distribution of Python. Then there are PyCharm, Spider, and Visual Studio Code, which are also some of the standard IDEs. Then there is a next generation of a web-based interface, a continuation of Jupyter Notebook, which is Jupyter Lab. So which is more like an internet-based one. So where you don't even have to install. You can either install Jupyter Lab, or you can just go to the Jupyter Lab website and just click on the link and get started there. So I'll use Jupyter Lab for the rest of this session to just demonstrate simple things about the Python data structures. It would be really useful if you have a Jupyter this thing installed. I can help you if you have any doubts. You can just go to Google Jupyter Lab and access that as well. So some of the fundamentals that we will discuss today include these things. So one is data types. So first of all, you should know how you represent in your data in a particular programming language, right? So like the data that you would be analyzing might be a numeric data. So it might be like a number, or it might be some sort of string, like a text data, like you want to analyze a text document. So how do you actually represent that particular data in Python? So that is generally the most basic thing before you begin with any other advanced analysis. So what are the data types that you have in Python? Then next come the data structures. So which is how do you, so okay, so data types are like what types of data we can have in Python. Data structures are like containers which hold these data. Like you might have for example, a table of data. Now, how do you put this table in a Python program? Or you might have one page of a document. How do you represent this entire page in a Python program so that you can then further analyze? So these are, because once you map from a particular page to a data structure, or say from a particular table to a data structure, those things are important, because then it's just purely you are inside the Python. It doesn't matter where your data came from. Then you have got control statements, which are the important things in any programming language, which is your standard if and else statements, which basically control the flow of programs. Like if this is the condition, then execute this set of programs. If not, then execute the other set of codes. Then you have the loops, which is again just iterating for a fixed number of times, just the loops and iterations. Then functions. So which is another important aspect in any programming language, which helps you create program modules. Like you can break down your big program into smaller sub-functions, sub-modules, and then create individual functions so that it is easier for you to analyze, it is easier for you to structure the code, it is easier for you to debug that, and also make it like more generic. Like if you, for example, say for addition, if you just create a generate function that takes x and y as input and returns the sum, then that works for any x and y. So these are some 5 key things that we will be discussing today. This is by no means exhaustive. There are quite few other things like concept of inheritance, or even classes, objects, many other things. But we will be discussing only those things that are relevant to our data analysis things. And if necessary, if we find necessary as we go forward, then we'll again incorporate any other things needed and discuss them again. Let me open my Jupyter notebook. So let's start with Python data types. So Python data types. So as I said, it's data type. When I say data types, obviously it's just like, how do you represent your data? So what sort of data would you have? Like it might be a numeric data, or it might be like a text document. So there are basically mainly these sort of data types in Python. So numeric, you have one, then you have got the string data type, then you have got the Boolean data type. So numeric is the numbers. How do you represent your numbers in Python? Then string is how do you represent a text in Python? Then you have got Booleans, which is binary values, so which is true or false. So how do you represent that in Python? So for example, let's say numeric data type. So when I say numeric data type, as you would know with numbers, so you have different types of numbers, like your number might be an integer, or it might be a float, or it might be a complex number. So if you want to say, so you might have something like this, so where x is equal to 10. So as you can see, 10, it's an integer. So, and you have got print, this is print type of x. So that would give you the data type of x, and then you want to print x. So if you run this cell, you can use shift enter. So so if you run this cell, that would give you the class of this is int. So x is basically an integer, and x is equal to 10. So it's printing 10. That is for integer. Then if, for example, you have y, which is 1.1, and if you print the data type and print the value, so that would be a float. So which prints 10, so which prints 1.1. So that would be float. Then you have got these are all So then you have got z equals 1 plus 2j, so which is a complex number. So if you print this, then it will print complex 1 plus 2j. So this is a wrong comment. So it should print 1 plus 2j, and this will print 1.1. So you can see here, so we have got three types of numbers here. So one is an integer, one is a float, another is a complex. You can also do these basic arithmetic operations. So we should be just say print x plus 2, x minus 3, x multiplied by 1. Then this double asterisk would represent power. So x to the power of 2, which would be x squared. So that is another simple thing. Then you have got, say, x plus equal to 1. So which is nothing but x is equals to x plus 1. It's more like an accumulator. So if you print x, that would give you, so that would be say 11. So then same thing with multiplication as well. So as you can see here, so this is just very simple example. So of the numeric data type that we would use in Python. Then we have got the Boolean data types, so which is very standard. So you have got say true and false. These are the two important keywords that you have. So these are the reserved keywords. So which means you can't you can't define a variable named true, because this is a standard keyword that's reserved in Python. So true represents the state of say 1, and false represents say the state of 0. So if you want to just print type of t, that represents a class known as bool, which is Boolean number. So this is an operator, for example, that compares whether t and f are equal. So it prints 2, because it compares not equal. So whether if t is not equal to f, so if I had written this, then it represents false, because here I'm comparing whether t and f are equal, and they are not equal. So it is printing false. So if my question would be whether t and f are not equal, then it would print true, because they are not equal. So that is Boolean data type. Then we have got strings. So You can use single quotes or double quotes for strings in Python. So for example, say we have got a string, say hello, so which is assigned to this variable hello. So if you want to print this, then it will print hello, that's one string. And len is an operator which you can use to get the length of the string. So if you print len of hello, that will print 5, which is the length of the string that we have. Then if you want to access the strings, say for example, you have got this string here. Now, if you want to access the particular character from this, then you can use it through indexing. So for example, print hello of 1. So within square brackets, hello of 1. So Python indexing starts with 0. So 0 corresponds to H. So 1 will give you E. Then if you want to access a range of indices, then you can say print hello of 1 to 3. So which would print EL. So which is EL 0, 1, 2, 3. So 1 and 2. So the always should remember another thing. So when you say 1 to 3, so when you write a lower index to upper index, so upper index is always exclusive and the lower one is always inclusive. So here 1 to 3 you have. So one is you have E, then it will print L, which is 2, but it won't print the other L, which is 3, because it is exclusive. So when you say 1 to 3, what it prints is the first one, the index at 1 and the index at 2. That's other way. Then another popular thing that you can use with Python is negative indexing. So which is sort of reverse indexing. So for example, before this range indexing, let me write another line here. Yeah. So if I just say print hello of -1, it will print O, which is the same as printing. If I want to print 4, there are 5 characters here. So which means 4 is the last one. So if I print 4, hello of 4, that will also print the same thing. So negative indexing is nothing but you just do the reverse. So or other simpler way would be to the negative indexing, you just add the length of the string to get the actual indexing. So -1, then you add the string +5. So that would give you 4. So which is what you're getting. Negative indexing is also very useful, especially when you have when you want to do sort of some descending order sorting and other things. So in some programs, negative indexing is a very useful thing to have. So similarly, for example, here you have -3 to -1 range indices, right? So if you add 5, this would be 2 to 4. So it means it should print the ones at 2 and 3. So which is L and L. That is how you would access strings. You just have a basic string variable, so which we have accessed now using a single index or a range of indexes, and then negative indexing. Then let's say you have 2 strings. So which is one is say hello and another is world. So how do you concatenate the strings? So string concatenation you can do using a simple plus operator. So you can see here. So if you do this, oh sorry, I didn't click this. So you have this, then you have hello world. This is just so for example, even if you remove this space, so if you want to have just this, so hello world. So you can just use a simple plus operator to concatenate both the strings. So here, if you want, for example, if you want any other separator, you can add the separator here. Say within quotes, you add comma, then you add here. So it would be hello comma world. Say you want to add hyphen, you can add hello hyphen world. So you can add any separator that you want and then print it here. And this is some sort of print form. If you want to print it in a particular format, like how you would have in say your standard C language. So %s, %s, %d. So d is for integer, s is for string. So you get it hello world 1, 2. So this string, and this one. You can also specify here %f and then how many digits you want to have. F is for float, and how many like if you want to have 2 precision, like a 2.53 or 3 precisions, 2.536, things like that. So this is very simple string concatenation. Another thing with strings in Python is you also have some inbuilt methods with the strings that you can use. Like if you want to capitalize a certain string, or like, for example, say you have this, S is equals to HELLO, hello. So if you want to just capitalize the first word, so S dot capitalize, if you just write that, so it will give you hello, this. Then if you want to make all the characters upper, then it would be S dot upper. That's one string method. Then if you want to say this is R right justification, that is print it right justify, like how you would have in your Word document, left justification, right justification, those sort of things. So this would be right justification, say this would be center, and this would be, yeah, this would be okay, yeah, I don't have the left one there. Yeah, so this is print S dot replace. So which is replacing the strings. So for example, here you have got S, which is a string. So S dot replace L with ELL. So wherever you find L in your original string S, replace all the occurrences of L with ELL. So you have got HELLO. So in place of L, you are replacing it with ELL, and of course the parenthesis as well, whatever is there within this codes. So you can see here HE, then you have got ELL, then again ELL, then O. So that is string replace method. Then this, for example, S dot strip would strip the leading white spaces. So for example, here you have got extra white space here before the word. So if you want to just get rid of the white space, then you can just write S dot strip, so that will get rid of the white space. So this is just 3 basic data types. One is numeric, where you have got integers, floats, and complex numbers. Then you have got the strings, where you represents the text documents and things like that. And then you have got the Boolean data type, so which represents the binary state. Then you have also something known as casting, so where you actually can convert one data from one type to another. Like for example, you want to so you have got you, instead of just declaring x equal to 10, you declare it x equal to int of 10. So which means your x will be explicitly, you have to make sure that x is 10. So for example, you have got y equal to 2.3. So you want to say z, which is int of y. So if you print it here, so it prints 2.3. Now you can see first it prints float, then it prints 2, because when it converts 2.3 to 2, it's obviously truncating it. So you're getting 2. From 2.3, the nearest integer is 2, and now the class is int. So explicitly, you can convert the data types from one to another as well. Then yeah, so that then if you want to create a string out of a number, so for example, you have got 10 here, then you just write str of 10. It would give you this. So which would be 10 is your string, and the class is str. So 3 basic data types and ways to convert within them from one data type to another. Then you have got operators, so which is basically which I discussed earlier, like arithmetic operators, the addition, subtractions, and then the logical operators. So when, say for example, you have 2 different conditions, so you'll have and, or, not. So you want to combine 2 conditions, or you want to have those sort of things. Then you got comparison operators, which I showed earlier. So equals, not equals, then the greater, less than, all equals. Then if we come to control statements, this is how you write a if else statement. So for example, x equals to 1, y equals to 2. If x less than y, followed by a colon. So this is what I was referring to when I said Python follows indentation. So you can see here. So this sentence, so it comes here. So there's 1 tab. So 1 tab indentation here. So you can have any sort of 1 tab, 2 tabs, whatever it is, but you have to follow a uniform indentation style within that program. Like your editors or IDs, whatever you're using, they would sort of normally give you the options to figure out your indentation. You can change that, but whatever indentation you do, you have to stick to that particular style of indentation within that particular program. Otherwise, it will mess up the entire scope, leading to other errors. Sometimes it may not even generate explicit errors. It may actually, I have had cases where like you have big programs, and then because of some scope issues, it's sort of gives you weird outputs. So which becomes pretty hard to debug. So you have got this simple if-else statement. So you have got this comparison operator. Then you have got this, which I said logical AND. So for example, x equals to 3, y equals to 2, z equal to 0.5. If x is greater than y and y is greater than z, then print this, else none. So this is a logical way of combining two different conditions. So you could have and or. So that's, you can see here x is greater than y and y is in turn greater than z. So that's one thing. Then then again using the or. You could also have nested if else statements. So where instead of else, you could have say something like elif. So it should give you else if. And again, you have say a condition here, say y less than z, something like that. Then you end up with here. So again, else here, and then again print. This would be more like a nested if else statement. So this is just a basic overview of how you would write. So as and when we encounter some programs, we'll again give more details. So this is a basic way of writing control statements. Then finally, you have the functions. So which is what I mentioned earlier. So where you have to sort of modularize your programs and things like that. So for example, def is the keyword that you use to define a function. So you have got this function. So say def hello world that takes input argument a number and does number equals number plus 2, right? And returns the number. So this is a function that you have defined. So def is a keyword, hello world is your function name, number is your input argument. Then inside that you do number equals to number plus 2 and return the number. So say for example, number 1 equals to 2, then you do hello world of number 1 equals to number 2. So if you print that, oh yeah, I didn't define that. So you run this, then run this. So you'll have 2 and 4. So which is you are sending 2 and then you're getting 2 plus 2, which is 4. Another popular way to define these functions, write them, is something known as lambda. So which so this is very useful concept. The same function, we can write it in a more compact way. And this is especially useful when we are writing some bigger programs. And we have got 1 or 2 examples where I can demonstrate. I'll demonstrate that. So for example, this entire function we can write like this, like this 3 lines. That's it. So instead of having 2 cells like this, so you see here we have got a function hello world, which takes the input argument number and it does number equal number plus 2 and returns number. So instead so you have the keyword lambda, which takes the argument number and returns number plus 2. This is known as hello world, right? So this is in 1 line, you are defining this entire function. Then inside this hello world, you are passing the number 2. So it gives the exact same output. So this 1 line is defined entire this thing. So only thing is so this is the format. So you have got the keyword lambda. So where you have got the input arguments and this is the expression. So you need to have, the only thing here is that when you want to write it in terms of this format, you need to have 1 single expression. So entire function of yours has to be sort of boiled down to 1 compact expression. And that expression, you just put it here. And this is your input argument. And whatever the expression is there, it will return you the result. So this 1 line defines your entire program. So that is a very basic introduction to Python data types, what the numeric, integer, and string data types that we have, and how do we write functions and control statements and basic operators. So before we move on to second part, which discusses Python data structures, if you have any doubts.
Someone raised the hand. Just give me a moment. I'll unmute them. Yes, Daniel, please go ahead. Oh, you're on mute. Would you please unmute yourself?
Yeah. I have a question.
Yeah.
Is the programming for the Python similar to the Java? Because I have already seen all these things in the Java as well.
Come again, sorry.
Yeah, I'm saying that is it similar to the Java programming? Python?
Yeah, there are some things that are similar. Some of the syntax are different, but some of the things essentially it's. I mean, yeah, some of the concepts are similar. Yeah, there are some differences, key differences. Though as we move forward, we'll discuss that further.
So there is another question by Vincent. What program should we be installing?
Yeah, so you have to. I assume you already have Python installed. If not, install Python in your computer. So before that, even you can just you can actually just how do I access Q&A? Oh yeah. Yeah, so you just have to install Python, and then normally most of the computers, especially the newer ones, you come with Python pre-installed. If not, you can just directly go to Python's website and install the Python. So it might be Python. Python 2 is slightly outdated now, so you can install Python 3, which is newer version is 3.6 or 3.7. And then you can use without installing anything. Like I said, you can just Google Jupyter Lab. This is what I'm using here. So you can just get started with the Jupyter Lab without installing anything. You can just write simple programs. Then you also have got Google notebooks nowadays. So which is again very easy to write your programs.
So
and share. Yeah.
Just to add to that, Nandakishor, I have just added the links of what you have mentioned in the chat session.
Yeah. Okay.
So would you mind just adding the link to the Jupyter Lab? I think I missed it in the
Okay,
chat.
okay, I'll add it.
Yeah. That would thank you. And there is another question. Can you please explain lambda part again? I think
Session 1. So it's pretty simple. So you can see here, this is how your lambda function would look like. So you have got the keyword lambda that you write, right? Arguments, expression. So here, like function, what is the format for a function here in the standard format? So this number is nothing but an argument, right? So def is the keyword, hello world is the function name, and this number is your argument, which you are passing to the function. So same thing here. So lambda, arguments, expression. So this is the input argument that you are passing, and expression is that expression uses your input argument and returns you the final value. Like for example, in our case, the expression is x plus 2. So number plus 2. So number is your input argument. You are passing this input number, and the function does number plus 2 and returns you that. So this is the whole lambda, this thing. So it is assigned to hello world. So when I say hello world of number 1, so number 1 is nothing but 2. So hello world of 2, when I do, so what it does is it passes 2 here. So 2 becomes 2 plus 2, 4, and it returns you 4. So this is a very compact way to represent, especially when you have one single expression. We will explore that in some later bit complicated problems, how it is very useful. Moving on to part 2. So some of the built-in containers. So we'll explore some of the important data structures and built-in containers in Python. So there are basically 4 important data structures or containers that we use in Python. One is a list, another is a set, another is a tuple, and finally a dictionary. So these are 4 key data structures that we use to hold the data. Now each has their own advantage and disadvantage. So let's start with list. So list, so how you would have an array like in a C program, right? Like when you define an array of say size 10, like that means you have a vector of 10 values, 20 values. So list is pretty much similar to that. You can have one single list of 10 values, or you can have a list inside the list. So a list is something like this. That you would normally define using square brackets. So square brackets are something that you would normally use to define the print. So yeah, it should be 5 and 0. So so you start with a square bracket and end with a square bracket. So this is your list entries. So if I just print this type of the list, so this is class is list, and it prints this list 3, 1, 2, 5, 0. Now there are 3 important things here, actually 4 rather. So that I have highlighted in bold here. That is, the list is, it's an ordered collection. So what I mean is the order in which you insert these elements, it will print like this, like 31250. It's here 31250. So you are accessing that order. It's not shuffled or anything. It's whatever order you put it in, you'll access it in that order. Second is changeable. What I mean by changeable is, I'll get to it in a different example. Then third is indexed. As in, using indexes, you can access the elements of the list. 0th index, first index, second index. Then fourth is straightforward, duplicate members. That is, you can have duplicate members, like you can have a 2, 2, 5, 5. So you can have duplicate members. So this is a very standard list example. And again, len is the operator here as well that you use to determine the length of a list. So if I use len of xs, that will give you 5, which is the number of elements that we have in this list. Now, let's first see how do we access the items in this list. Pretty much similar to how we did with strings. So you have got this excess of 2, which is nothing but access the third element because the indexing starts at 0. So it prints 2. Then the negative indexing, so which, as I said, you count reverse. So we have got length 5. 5 minus 1 would be 4. So it prints the fourth one, which is the last one. So -1 basically means print the last one. So that's the starting index in the reverse direction. So which is again excess of 4. So you can see here both the things are same. Then you have got excess of 2 to 4. So which means 2 to 4 you get the indexes, and 4 being exclusive. So you print the second and third, or like the here, this one, 2 and 5. Then you have got this another type of range indexing where you just give the lower index and you don't give the upper index. So when you do this, what it does is inclusive of this. So for example, 0, 1, 2. So from 2 here to 5, 0, print all of them. So 2, you are given the lower limit. If you don't give the upper limit, that prints starting from that index, print the rest of the list. Same thing in the opposite direction. So if you do this, starting from the first index, print only till this. Again, that print only till this means that the previous one only will be printed because it's exclusive. So upper limit is always exclusive in Python. The lower limits are always inclusive. Then the same thing with negative indexing as well. Now, I said here, so one is ordered, that was very clear. Second, what I said was changeable. So what I mean by that is you can change the list elements. Like for example, xs is 31250. Now, here the third index, excess of 2, instead I assign with some FO. So it changes the list element and now it prints 3150. Now you can see this list is a sort of a hybrid list. So as in there is, you can't say like it's like it's a homogeneous thing, like how you'd have in an array or whatever, like this array whether it contains integers or this array whether it contains these floats, numbers. So list can contain pretty much any types of data. So you have got 3, 1, which are numbers. Then you have got this string, then again numbers. So you can modify the list. Another way is append. So here at a particular index, you inserted this. If you use append, then it will append at the end. So just append at the end. Then you want to assign a smaller list. So for example, you have got this list of list 8, 9 here. And so positions 2 to 4. So if you do this, so here 3, 1, right? Then 2 and 3 will be assigned 8 and 9. Then again, you have got 0 and bar. So indices 2 and 3, that is the indices 2 and 3, that is the third element and fourth element, are to be replaced by 8 and 9. So that is how you modify list in this case. Then if you want to do say xs.pop, so which means just remove the last element, just opposite of what you would do. Append is automatically at the end. So pop would be do the same thing. So this is print x and xs. So bar is popped out and this list is remaining. Then remove. So if you want to remove particular element, not just the last one, particular element. So if you want to remove 8, so remove 8. So you end up with 3190. And ultimately you just want to delete the list from your memory. So you just use the del keyword. So del the list and then print. So it will give you an error. Name access is not defined because you already deleted it here. So it's no longer present in the memory. So if you try to print that, it will give you an error. Then if you want to join two lists, like how you did with prints with strings, so exactly the same thing. You have got, say, a list 1, X, Y, Z. Then you have got list 2, which is 1, 2, and 3. So if you want to combine the two lists, you have got list 1 plus list 2. That would straight away combine the list. If you want to iterate over a list, like if you want to run a list, so for example, because ultimately list is what? List is a collection of items. So you've got like 3 elements in this list, 5 elements in this list. So you want to go through the individual elements in a loop. So if you want to iterate over that particular list, then you can do it like this. Say, for example, you have got a list animals, which has one entry cat, another entry dog, another entry monkey. So you can add for animal, in animals, print animal. So if you do this, it will print cat, dog, and monkey. So for animal, in animals. So in is a membership operator. So it just says for every animal present in animals list. So first cat, then dog, then monkey. That's one way to go about it. You can also use some function known as enumerate that will also give you a numbering. For example, if you do this for idx, comma animal in enumerate of animals. So then what it will do is idx will give you numbers 0, 1, 2 because your list is of length 3. So to avoid confusion, I'll remove this idx plus 1. So let's just print this. So you got 0, 1, 2. So for idx comma animal in enumerate of animals, so that at 0th position in the list you have a cat, at first position in the list you have a dog, at second position in the list you have a monkey. So that's sort of basic concepts of the list, where you have a list, you create a list, you remove elements from the list, you determine the lengths of the list, modify the list, join two lists or loop through a list. So for example, let's do this practice one. For a list X in Python and a number Y, okay, we have given a number Y, count number of occurrences of Y in the list X. So for example, we are given this list. Say X is 3, 1, 4, 22, 5, 4, 10, 4, 100, 4, 30. X is one list. Y is 4. How many times does 4 appear in this list? So 1 here, 1 here, 1 here, and 1 here. So 4 times the number 4 appears in this list X. So if we want to do that, so let's write a function for that so that whatever list we pass, we should be able to execute that program. So like how I said, so we have got def, the function name is count Y in X. Let's do that. And the input argument that we are facing is, we are getting is X and Y. X is the list and Y is the number. So it's very simple. Like how would I did here in the loop for val in X, that is take every entry in X. If that entry is equal to Y, then increase your counter. That is count becomes count plus 1. Initialize the count to 0. So count this in a loop. So if they are equal, so run this definition, then say I use this in X and Y, and then count Y in X function, X and Y. So that gives you 4. There are 4 4s. So that is one approach. It's a very simple brute force approach. So where you just run a loop, compare with every single element in the list. If it is equal, then increase the count. Another is your list has an inbuilt operation known as dot count. So that is X is your list and Y is something that you want to count in list. Then all you have to do is X dot count of Y. If you do X dot count of Y, then what it will do is it will count the number of occurrences of Y in X. So run this program, you'll again get 4. This is a more standard compact way where you just have a standard function that is available with the Python list. So you just use that X dot count of Y, return the count. So that is Python lists. Let's move on to tuples. So which is pretty much the same thing. As I said in the bold format. So you got ordered. In lists, it was changeable. Now here it is unchangeable. So that's one key difference. Rest are the same. So ordered, indexed, duplicate members. Three properties are same between tuples and the list. The key difference being unchangeable. So you cannot change the entries of the tuple. So for example, and another key difference is in lists, you use square brackets. In tuples, you use parentheses. So same thing. So x equals fruit, veg, animal. This is a tuple. So it's class tuple and it prints like this. So same thing, use the length. You have got length of 3. It is indexed as well. So which means you can use the standard indexing that I mentioned. So same negative indexing, all the things are the same. So you have got range indexing, which is pretty much the same. Now changing tuples. So for example, you have got x equals to fruit, veg, animal. Yeah, fruit again. It allows duplicate members. Now let's say like how you read with list, you want to do x of 1, you want to analyze it with banana. So you can't do that. Its tuple object does not support item assignment. So you cannot modify tuples. So you can't so that's one key difference between what you have in a list and what you have in tuples. So, but within that, let's see. So instead I declare this. Now this worked because here we have a tuple, right? This is one element. This is another element. This is another element. This element inside the tuple is actually a list, right? So which you can see we have defined using square bracket. So 0th element in the tuple is fruit. First element is veg. Second element is a list. Now in that second element, I want to modify the 0th element. That if I run this, so it worked. And then now if I want to print, you can see that animal has been modified by banana because this is a list inside a tuple. Whereas if I would do that to the, if I did do here tuple entry, that I cannot modify. And if I want to say join tuples, same thing as list. So for example, you have got tuple 1, which is x, y, z, and tuple 2, which is 1, 2, 3. So if you do just tuple 1 plus tuple 2, that would give you this one. So it would be just concatenating the two tuples. So for example, let's do this program. Write a Python program to count in a to count in a tuple until an element is a list. For example, we have got this tuple, right? So we have got this entry high, then we have got entry 1, we have got entry 0, then we have got this list. So what the program is asking is, until this list comes, count the previous ones. That is, count this, count this, count this, and give me the number of these occurrences before we hit a list. So we can initialize the count to 0, and then we can iterate over this tuple, right? So for val in x, so for each individual entry in the tuple, if is instance. So is instance, what it gives is if that this particular instance is a list or a tuple. So if is instance of this val, if it is a list, then stop, break. If it is not, then count equals to count plus 1. So if I run this, it will give you 3. So 1, 2, and 3. There are 3 entries in this tuple before we hit a list. I hope that is clear. So there are 2-3 different functions here. So one is the same iterating over a tuple, like how we did in a list, right? For val in x, if is instance, so it checks whether this val is a list. If it is so, then stop it here, break. If it is not the case, then increase the count. So once it comes here, it breaks and comes here and prints your count. which is 3 because high, 1 and 0 until we hit a list. Now another small useful function with respect to tuples that you should know is this. So which is, say, for a list or tuples, actually it applies to both. So for example, you have a list of strings like, say, apple, orange, banana. So it's one list of 3 strings. If you want to make one big string out of it, combine all of these things, then this is a standard function. That is, this separator dot join map this string to string list. So if you do this, this is what you'll get. So let me just first run the program. So it will give you apple hash orange hash banana. That is, map is very simple. So it just maps this thing to strings, right? And then what dot join does is it just, whatever entries are there in your list, it joins all of them together to compute one big string. And this hash is your separator. So for example, if I change hash to hyphen, it will give you this apple hyphen orange hyphen banana. Or if you want to just give a space here, then it will give you space as a separator here. So it will just create, so if you have 3 elements, 4 elements, it doesn't matter. So exactly same way it works with tuples as well. This is another very useful feature if you want to print certain things in a particular format, so which we'll come to later. So this is a key difference. So you have got lists and tuples. Your lists are mutable, whereas tuples are immutable. And lists consume slightly more memory compared to tuples. So that's because of, but tuples are, that's why, little faster. So lists have more functionality. So it's not, there is not a lot of significant difference, but it's more like when you have some, when you want some read-only properties, when you don't want any external modification to some of your contents, or faster, some of the structures to be faster when you are operating on a very large scale data set, then sometimes tuples are very useful. That's the key difference between lists and tuples. I hope that is clear. So coming to the last 2 elements of this one, this today's session. So we have got 2 more elements, that is sets and dictionary. So set is an unordered collection of distinct elements. So it's unindexed. So that is, you have got the sets, right? It is unindexed. That is, you cannot access the elements of this set using indices, like how you did with a list. Like you can't have here, like animal of 0 or like that, you can't access with sets. So instead, you have to, say, for example, iterate over the sets. For example, for x in animals, print x. So you would get it with this. Another important property of sets is that duplicate members are not allowed inside the sets. So you cannot have, say, 2 cats. You cannot have, say, 2 dogs. So sets have unique members. So this is one important property that you may use in any of your programs. Say, for example, you have got a list where you want to sort of find what are the unique entries in the list. So one popular way you could do that is just convert your list to a set so that it automatically becomes a unique entries, and then convert it back from a set to a list. So so you can print like this as well. So print cat in animals. So if you do this, it just prints, say, you can see here true and false. That is, it checks whether cat is in is a membership operator, like I have said earlier, whether a particular entry is present in that list or set. That's what it checks. So print cat in animals. So if cat is present in animals, it's printing true. Fish is not present in animals, so it prints false. Then if you want to add to the sets, you can use this function, that is animals.add wolf. So then you can write this. So print wolf in animals. Now it prints true. So animals.add cats, adding an element that is already, see, for example, here, it did not change anything. So because cat is already present, so it did not add one more cat. Then remove, again, like how you do with a list. So you just do animals.remove cat. That's one thing. Then you have got discard. So that's another way to remove entries from your set. Works pretty much similar to remove. So animals.discard wolf. So if you print the same thing, it discarded the wolf, and you have got dog and tiger. Then joining the sets. So it's pretty much like how you do union of the set. So set 1 is say cat, dog, and tiger. So set 2 is parrot, sparrow, and crow. So set 3 would be set 1 union of set 2. So which is just like how you do set operations union. Then you can also do update. So where instead of doing set 1 and set 2 union, you are creating set 3. Whereas what set 1 would do is update your set 1 dot update set 2 would actually update your set 1 with the entries from set 2. You're not creating a new set. You're just updating the older set itself. Most of these functionalities, as you can see in the lists or in the sets or in the these things are pretty much similar, but for key differences. Some do not allow duplicate members like set, and you cannot access them using indices. And then some you can access using indices, but not the other one. So so let's do a practice program using sets. The question asks, write a Python program to find common elements in 3 given lists, list 1, list 2, and list 3 using sets. So as you can see here, list 1 is given here, right? List 1 is this. Let me just put this in a different cell just so it's clear to understand. So you have got 3 lists. So which is this? So list 1 is this, list 2 is this, list 3 is this. We just have to find the common elements among all the 3 lists. So let's define a function that is common element 3 lists. The input arguments are list 1, list 2, and list 3. DEF is your keyword, right? So once you receive the list, you are converting all the 3 lists to sets. So set of list 1 becomes set 1, set of list 2 becomes set 2, and set of list 3 becomes set 3. Once you have set 1, set 2, set 3, so common between all the 3, you can also sort of split it as common of 1 and 2 and common of 1 and 3. So just like how you had function union here, you also have a function intersection that gives you the intersection between 2 sets. So set 1 intersection set 2 is set 1, 2. Then set 1, 2 intersection set 3 is set 1, 2, 3. Once you have the intersection, then you convert it back to a list. So list of set 1, 2, 3. So this is a list constructor. So list of something will convert that particular data into a list, just like how you convert it to set here. So list of set 1, 2, 3 will give you list 1, 2, 3, which you are returning back. So for example, if you run this program, you'll get 40 and 23. You can see 40 is present here, 40 is present here, 40 is present here. 23 is present here, 23 is present here, and 23 is present here. So what you did was just finding common elements to all the 3 lists by converting each of those lists into sets and then performing set operations and converting it back to your list. So that is one example of sets. Then finally, what you have is dictionaries. So dictionaries are like how is pretty similar to some of say like a map object in Java. So where you have 2 important things known as keys and values. So you insert a key and you insert a value in a dictionary using a particular key, like for example, how you would access in a standard dictionary, like how say this page contains all the English words starting with A, right? So in that case, A would be your key and all those words would be your values. Say for example, all of those words you can put it in a big list. where each entry in the list would be a word in that particular page. So your dictionary would contain key as A and the value as a list that contains all those words. So for example, you can create a dictionary like this. D equals cat is the key and say it's cute, and dog is the key and say it's furry. So this is a new dictionary. So if you if you print this dictionary, you print it like this. So you have got curly braces here, in dictionaries. So cat is the key, cute is the value, dog is the key, and furry is the value. So you can access the keys and values like this. If I write d dot keys, print d dot keys, that will give me the keys. And if I say print d dot values, that will give me the values, that is cute and furry. These are the keys and values in dictionaries. So if you want to access the dictionary entries, so you have got, say, for example, d of cat, print d of cat. So which means this is your key, right? Now you should know that dictionaries are unordered, as in they won't appear the order in which you insert them. So it's not like list whatever order it's just sort of randomly shuffled. There is another thing called as ordered dictionary that appears in collection, but we're not going into that. So print d of cat. If I do print d of cat, it will print cute. That is, cat is the key. So for example, again, if you want to compare with a standard English dictionary, so if you were to sort of print a word that starts with A, then print d of A. If you do here, it would print a big list here that has all the words on that particular page starting with A. So print cat in D, true, because cat is present in that dictionary. Print d of monkey. Monkey key is not present, so that would produce an error. So same thing again. Then if you want to modify a dictionary, say you want to insert a new key, so you can simply do this. You have got the dictionary D, right? So D of fish equals wet. You are printing an this thing, so that would print. Now your D would look like this. That is, print of D would be like this. Now it has got entry fish as well. Print d dot get get an element with a default prints wet. So d dot get fish, so that will print wet. Then del is the keyword again, which you can use to delete a particular element. So delete this particular, delete d of fish. So if you do that, then it prints not available, because fish is not available. Then d dot pop. So if you do d dot pop, it pops out that particular value. So when you say that particular value, so you can see here, for example, d dot pop of cat. So which means it will remove it will remove the cat as well as the corresponding entry cute as well. So this is more like one entry. So where you have got key as well as value. By using this key, you are removing all the value. So as in tear away that entire page that contains the words with starting with A. So that's the key, and you're removing all of the words with that particular key. If you want to iterate over a dictionary, say you have got D, person 2, cat 4, spider 8, say person like 2 legs, 4 legs, 8 legs. So then if you want to iterate over that, so you can print like this. For animal in D, print. It just prints the keys, right? Person, cat, spider. So if you want to be more precise, so that it prints the keys. So if you want to print the values, same thing for animal in D, print legs D of animal. So D of person would be 2, D of cat would be 4. So if you print that, it will print the legs. You can also iterate like this. So for D dot items will give you both values and keys. So for animal comma legs in D dot items. So animal will get the key part, legs will get the value part of the corresponding key. So if I do this, it will print person 2, cat 4, and spider 8. So this again, if cat in D, then print cat is present, else print error. So standard if else, how you would use. So yeah, same thing again. So you can see here, for example, here I have mistakenly typed it here. These two lines are not aligned, are not indented. So because of which you can see here it is red. Now you can see it turns green. So that's sort of how it shows that the indentation does not exist. So if the indentation does not exist, that should produce error. Then if you want to copy dictionaries, so for example, you have got a dictionary D, right? Person 2, cat 4, spider 8. You want to do dict2 equal to D. So you want to create another dictionary, second dictionary. So let's say we do dict2 equals to D. So D is our dictionary, dict2 is our dictionary. So we have copied, right? Now I'll modify dict2 by adding elephant, which has got 4 legs. So my dict2 becomes person 2, cat 4, spider 8, and elephant 4. Let me print my original dictionary D as well. Now if you see here, original dictionary D is modified as well, right? What I did was dict2 of elephant equals 4. But what it has done is it has actually modified the original dictionary D as well. So that is one thing that it's very important to remember. That is, you can't just simply use the assignment operator equals to copy one dictionary to another, because it always points to your same original dictionary. So instead, let's say D is this. You can use dot copy function. That is dict2 equals D dot copy. Now if I copy this, and let's do the same thing again. Now I modify dict2, right? Which is this, and I print D. It's not modified. So if I use simple assignment operator to copy one dictionary to another, then it does not work because it points to the same original dictionary. This is one way to use the dot copy operator. Then you can also use this property as well, dict of D. So that is also another way to copy from one dictionary to another. Dict is a constructor, so you can use dict of D as well. So in that case as well, if you modify, it works. So you can see here, I modified dict2, but D is fine. So these are the basic properties of dictionaries, keys and values, how you insert a new key, how you get the corresponding value, and things like that. So let's solve a particular practice problem here. So given a list X, a dictionary Y, and a key K. So we are given one list X. We are given a dictionary Y and a key K. Print value of K from the dictionary if the key K is present in both the list X and the dictionary Y. So if the particular key is present in the dictionary as well as it's present in list, then print its value from the dictionary. So for example, it's very simple. So again, let me make this in a different cell. So to make it clear. So for example, we have got list X, so which is this. We have got dictionary Y, where key is 11, value is 1000, key is 22, value is 2000, key is 29, value is 3000. Now K is 11. Now you can see here, right? 11 is present in this as well as this. If that is the case, then my function should return the value that is corresponding to 11, which is 1000. Ultimately, 1000 is the answer that we are looking for, because my 11 is present in this dictionary key as well as in this list. So we should get the corresponding value of this key. So let's define a function, find val for key. So X is the list, Y is the dictionary, and K is the key. All it requires is one simple if statement with a logical AND. So you have got if your key is present in X, that is if your in is again a membership operator like how I mentioned. So if key K is present in list X, and, so logical and, if key k is present in y dot keys. So what is y dot keys here? So for example, if you just take y, so this is one of the, as you can see, this is one of the advantages of using your Jupyter and also with Python. You can just take your small snippets of program and then just verify them as and when you want. So for example, you have y here. So if I do print y dot keys, so that will give me the keys, which is 11, 22, and 29. So, and x is my list, so which is this. So if my key is present in x and key is present in list, then return y of k, because y is my dictionary, y of this thing. So I run this function and I print this, so it will give me 1000, which is what the question asks. Then let's have another practice program. So which is, for a given dictionary in Python, write a program to find the sum of all items in the dictionary. So for example, we have got this dictionary, right? A, B, and C. So we want 23 plus 61 plus 99. So which is pretty straightforward. All you have to do is, so like for example, so we have got this function, right? Sum item. So you're passing the dictionary. So let's define a temporary variable temp sum equals 0. For every key in the dictionary, that is for key underscore val in x underscore dict dot keys, temp sum equals temp sum plus x dict of key val. So your dictionary in that particular key value. So yeah, it's pretty simple. So you just iterate through all the keys. So for key underscore val in x dot keys, so this loop, for example, will give you, if you print, these key vals will be A, B, and C. So x dict of A is 23, x dict of B is 61, x dict of C is 99. So in a loop, and this you are initializing to 0, so you are just summing it up in a loop. That will return you the ultimate sum, so which is 183 and minus 921. So these are some key properties of dictionaries. So what we did here was basically concentrate on 4 important data structures in Python. You have got the list, which is square bracket and modifiable. You have got the tuples, which is parenthesis and not modifiable, it's read only. But pretty much list and tuples are very similar, except for these minor differences. Then you have got the sets and dictionaries, which do not allow duplicate members. Then you can do the set operations and all. Sets, you can actually think of sets like dictionaries without values, right? So in a dictionary, you have got keys as well as values. Sets, you can think of as just collection of keys. So you only have the keys in sets, you don't have the values. Building on top of the sets, you have dictionaries where in addition to the keys, you also have got values. So these are the 4 sort of important data structures which we will be using throughout, because ultimately this is how, like, again, as I said, like for example, say you are given a table of a data, like some energy monitoring, some data, or energy monitoring at a household or a period of time. So you'll have like an Excel table. So how would you represent? So for one example, you could represent that in a list of lists, like where you have a big list for one particular household, say one particular area, for example, say one pin code, you have got one big list, and within that list, first list represents house 1, second list represents house 2, so on and so forth. So that's one example, for example, how you represent like that. So there are different ways. So when we explore some bigger data and like examples, so that will be clearer. There are, of course, different data structures as well, far more efficient data structures, which we'll be discussing in next week. So I'm stopping here as far as just explaining this is concerned, because I don't want to cram too much into this one session. As you would have received this link for the HackerRank, this thing here. This is the one. So I am assuming I am again putting the HackerRank link here, the contest link. So you just join the contest. and start with the first I'll actually display the program here as well, so you can just see those programs and try to write your codes and run it there, and see how you go. Of course, we'll do this till the end of the session, so if you have any doubts or anything, you can. So this is the link, which I'm pinging it here in chat. Yeah, so use this link to, okay, yeah, use this link to join the link that you see here. So once you join the HackerRank contest using this link, so go to the challenges tab. So here, ignore the scores and stuff. So first, for example, first open the Python if else challenge. So I'll give you guys some 5 minutes. Let me know if you can come till this page.
Victor, the link is in the chat. Could you please?
I know when I put it in the chat. I think.
Oh, sorry.
It says two panelists. Is it like some?
I have just sent it again. Sorry, I have just sent.
No, I had to make it panelists and attendees here. Sorry, actually,
yeah.
I put it, but yeah, I wasn't aware of that. And now I have put it again. Panelists and attendees. So I assume you can see. Please let us know in the chat if you cannot access this page. It's a pretty simple problem that just entirely rests on just Python if else, just to make sure you get used to it. So this is, you can safely ignore these rest of constraints if it makes it more confusing. All the question asks is this: given an integer n, perform the following conditional actions. If n is odd, print weird. If n is even and in the inclusive range of 2 to 5, so 2 and 5 are both included, print not weird. If n is even and in the inclusive range of 6 to 20, print weird. If n is even and greater than 20, print not weird. So as you can see here, so if it is odd, then that's it. So you just have got to print weird. If it is even, then there are 3 subconditions depending on if it is in the range of 2 to 5, 6 to 20, or greater than 20. So it just says the input format, the constraints are n in the range of 1 to 100. That's fine. That doesn't matter. So for example, if the input is 0, so if the input is 3, it should be weird because it's odd, print weird. So if input is 24, for example, 24 is even and greater than 20, so it should print not weird. So here you should write your program. So this is import statements are another way, are a very important way to import libraries in Python. Like here, import math. So it imports Python libraries that give you mathematical functions. So import random. Random is a library that is very useful if you want to generate random numbers for some of your functions, like a starting point, starting seeds, or random numbers. So some of these things we'll get into later. So you just have to write your functions here. So you can see here, this is another interesting sort of nugget. So if underscore so name equals main. So what is the use of this line? So when you have a big Python project, right? So you might have 2-3 Python files. So you have one Python file from which you are calling a function in another Python file. So like how I said about say addition. So you have one Python file, main file, in which you are inputting numbers, running, displaying, doing something. And you have a main function file, which is nothing but takes the arguments, returns your values. So when you have 2-3 files, whether your particular Python file, whether it should execute itself as a main or whether it is being imported by some other Python file, that is decided by this condition. So if name equals to main is whatever file this line appears in, that Python file is executed. It does not work as a module or anything that other file imports. So for this program, ignore all of this. So you just come here, right? So you have n. So start with n, and all you have to do is do this. So if n is odd, print weird. So as you could see, so one way to check whether n is odd or n is even is through your division by 2. So if it is divisible, whether it is divisible by 2 or whether it is not divisible by 2. So we can see the solution here as well. So this is pretty much the solution. So for example, if you want, where did I go? Yeah. So this would be your solution. So if n%2, that is when you divide it by 2, if it is not 0, right? If it is not 0, that means your number n is odd. Then print weird, because you have one condition here. If n is odd, print weird. Then you have got, if n is even, you have got 3 subconditions. So else, so if n is not odd, then the only other thing is you don't have to have another if here because n has to be even. So inside the else, you have 3 conditions here, n in the range of 1 to 6. Now, why have I written 1 to 6? Because you can see here, it says inclusive range of 2 to 5. So if I write here n greater than 2, n less than 5, it's just greater. It's not an equal symbol. If I had used equal symbol, then it would be 2 to 5, greater than or equals 2, less than or equals 5. Then that would be fine. Since I'm just using greater or less symbol, so I'm just sticking to 6. So 2 to 5 range, not weird. Then 6 to 20 range, weird. Else print, not weird. So that's, and then do this. So run the code here to verify your output and then submit the code. So I'll give you a few more minutes if you have any doubts. I'll just check submissions here, whether you are able to submit. View all submissions. Okay, that's good. I have 4 accepted. There are 4 to 5 wrong answers because probably that does not work for 1 or 2 conditions. So you should see at the top, there will be test cases 1, 2, 3, 4, 5, 6. So like for some of the users here, I think it might have failed in some of the test cases. So for example, their score says, it doesn't say perfect 10, it says 8.33 or 6.67, depending on how many test cases you might have gotten wrong. It has to work for different cases, different, like for example, there are 3 to 4 conditions, right? So the test cases would include examples for all those conditions. Give it a go. Once we finish the session, we will share these solutions for this problems. These are publicly available problems on the HackerRank, so it's not any custom problems or anything. Let me refresh my page. Okay, page 2. So let's move on to second problem then. So which you would be using there. So this is even simpler problem. This is a pretty straightforward problem. So it's on just loops. The provided code stub reads an integer n from the standard input. For all non-negative integers I less than n, print I squared. So for example, if you are given 3, then for all I less than n, print I squared. So that would be 0, 1, and 2, which are less than 3. So you have to print 0 squared, 1 squared, 2 squared. So you have 0, 1, and 4. So again, you don't have to bother about the constraints here. That is more like they won't be giving any input greater than 20. But if you write a generic program, that should work for pretty much any n. So if you sample input is 5, so that would be 0, 1, 4, 9, 16. So your sample input is 5. So you'll have from 0 to 4. So 0 squared, 1 squared, 2 squared, 3 squared, and 4 squared. So same thing here. If name equals main, so you got the n here from this raw input. So you just had to print here. this is a pretty simple this one. So just like how this would work. So you just have to use the function called range. So a range is something like you can see here. So range of, if you just write like this, range of say 10, if you write like this, it actually creates an object. It's called a range object. So you can see here, it's a range object. If you just write range of 10, that will create a range. Lower limit is 0 and upper limit is 10. So range of 0 to 10. So if you do this, now you can actually use this range to create different types of objects. So for example, if I do